Alright, for this one we have to find the nodal voltages at this point and this point. But the problem with this is this 2-volt source. Because if we try and like have a current pointing in this direction, it'll be we can't really easily figure it out because it'll be okay. So let's say this current is I, and we have this to work with. So it'll be V1, then increases by 2 volts plus 2 volts, and this is equal to V2, okay? Because as the current moves here, it increases by 2 volts as it's leaving the positive terminal. But we can't really find a way to get the current I using this. So what we're going to do is we're going to set this equation up and then ignore this 2-volt source and then pretend this is one whole node, okay? So that means all the current that enters this node is we can write it as one equation. So all the current that enters this one supernode is equal to all the current that enters this one supernode. So let's call V1 and V2 node because it's one supernode. And let's write the equation for it. Let's start by writing the direction of currents first. So let's say I1 is moving in this direction. Then let's say I2 is moving here and I3 is moving here. Recall this is 0 volts as this is the ground node. So let's start by writing the equation. So we see 2 amps is entering this giant supernode, so it'll be 2 amps. Let's see. Okay, then we see I1 is also actually no, not I1. Let's wait for that later. Nothing else. Oh yeah, wait. I1 is entering the current entering the node from here, so it'll be plus I1, and this will be equal to I3, which is leaving, plus I2, which is also leaving, plus 7 amps, which is leaving. And we notice that I1 is leaving from here. So plus I1. And notice we have I1 here and I1 here. So these two cancels out. So we don't even need to worry about this section. So this is the equation we've got right now. Now let's solve for I3 and I2. So I3, it goes from high potential V1 to a low potential 0 volts. So it'll be V1 minus 0 all over 2 ohms. Then I2 is the same thing, with V2, which is the high potential, to a low potential, which is 0, all over 4 ohms. So let's substitute that into our equation. So it'll be 2 amps equals V1 over 2 plus V2 over 4 plus 7. Now we have this equation, but we have 2 unknowns. But we can substitute that unknown using this equation we did before. So it'll be, it'll be 2 plus V1 over 2 plus V1 over 2 over 4 plus 7. Okay, that's the big equation we've got. So, sorry. 2 equals V1 over 2. My apologies. So let's bring the 2 to the other side. So it'll be 5 here. This 4 we can break up. And let's see what we get. The 2 over 4, that's just 1 over 2. So it'll be 5.5. And then we have to let's solve for the other portion. So this portion, it will be 0.75 V1. Now let's solve for V1. Let's bring the 5. This is all equal to 0. So let's bring the 5.5 to the other side. Divide both sides by 0.75. And then we get an answer of minus 7.333 volts. So that's what V1 is. But let's find V2. So recall V2 is equal to V1 plus 2 volts. So V2 will be minus 7.333 plus 2, which is minus 5.333. And that's your answer.